All right. So welcome to today's class. The last class we held was we discussed about command line interface, graphical user interface. How to successfully navigate your way. How to navigate using your command line. So I'll just kind of do a brief what would I call it? A brief revision of the things that we've said so far. So all the things we've been doing so far are all boring, 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 boring things. The reason is because for you to fully use these tools, right, you need to understand how you can even navigate your way through the computer or your laptop. At this point, the computer is not just for you to watch movies, do Microsoft Word and all those things. The computer, there's so many things that the computer is capable of doing that we don't even know about, that you yourself you don't know about. So those are the things that we treated during the last class. So now during the last class, we'll be using two major tools, right? We're using two major tools. Let me just open my notes. I have a note here. Where is the notes? I have to look for it here now. All right, so this is the note here. So we'll be using two major tools. Yes. So the two tools we'll be using is we're using the text editor and our Git bash, right? So the text editor, it stands is what we use to write our programs. So I'll be teaching a little bit of some computer science, terminologies as well. There's the how should I call it, street programming. The street programming is programming without you even fully knowing what the concept of programming really even is. Just like we have how to explain it. We have the corporate programmers. Okay, let me just call it corporate. The corporate programmers are the ones, they have the certificate, they've gone to school, they did degree, they've done so many things relating to mathematics, they've done linear algebra, calculus, all those things that helps in writing algorithms and all this. All those ones are just jargons, in book. But when we talk about street programming is you going in, you don't really understand too much of what it really means, but you already know how to do the implementation. So I would say I for myself now, I'm this time now giving it the name myself. I learned the um I learned the street programming first before I even started knowing all those big terms in programming, like regression, decision tree, all those things that relate to AI, deep learning, all those things. We have the what do they call it? All those big words that they give all those things in programming. So, but what I will do is that I'll be marrying both of them together, So we'll bring in the street programming, I'll also bring in the corporate programming in a sense where I'll be explaining some key concepts in programming as well as the implementation of it. So there's some corporate programmers, you just wear your tie, your suit, and you go to work and blah blah. What did you just do is just all those things that they were taught in school was just straight out from textbook, but when we see the street programmers, the rugged programmers, those are the ones that had to learn this thing by themselves. They learn how to do the work. They learn how to actually implement these things. So now, the first thing I really want to explain is what programming itself really means. Okay, so I'll be using some layman terms, to explain these things, and I'll also use and give you the right definition of those things. Right. So the first definition I want to give you is what programming really means. So I'm not going to sound too much of a philosopher, but programming itself is just based on your mindset. It's based on how you can think of a problem and bring a solution. So all those things, all those technologies that you are using is just one programmer or someone that just sat down behind. The person self that even thought of the solution was not even necessarily the person who wrote the code. Like Steve Jobs now, he thought of the iPhone, but was not the one who built the operating system. He was not the one who sat down and built Mac, or was able to practically explain the solution to the CTO. The CTO stands for Chief Technology Officer. In all corporate companies or an IT company, you always have a CTO. So the CTO itself is in charge of anything relating to tech. So if it's a software company, the CTO is the one that thinks about what programming language you are using, what technologies you are using, servers, and all those things. CTO also covers, bringing in developers on board that will work in different teams, the front end team, back end, DevOps, and designers, engineers, and everything. So that's CTO job. So Steve Jobs was able to fully pass that solution to somebody. So what I'm just trying to explain now is that there are a lot of programming language. I can't even count them. As we're speaking now, maybe this week a new programming language is just coming out. Next week another one is just coming out. But I will try and, as much as possible, to list some of the important programming languages for you. Let's say first of all we have Python is still the guy. We have Python. Maybe number two, let's say JavaScript. Let's say number three, we can say let's say C plus C. Let's say C. Four, we can now put maybe let's say TypeScript. We can put TypeScript, and let's say the fifth one, then let's put either Java stroke C sharp. These two, the five, I don't even know. There's a lot of comparison for that part in the internet, but to me, I feel C sharp is better than Java, but that is based on my own experience. So let's say these are like the five top programming languages. So all these programming languages now, they have their own particular way that they write. Okay, let me before I even go further, let me even explain what programming is. Programming in a layman term is just you as a developer writing series of instructions for the computer to understand. So you are giving the computer a series of instructions that number one, do this thing. After doing this thing, I want you to do it this way. After doing this, I want you to do it this way. So it also goes deep in the place where we call procedural programming language and what the even second one? Declarative. So declarative means I just declare and the program the code itself fix the problem. It's declarative and imperative. Yeah, declarative means I'll give a step-by-step process. I say, okay, number one, okay, let me give an example. Let's say I want to tell my computer now to help me wash my clothes. What I will do now is I'll write my code in this way. I can say number one, pick the clothes. Then I can say number two, put the clothes in the machine. I can now say number three, giving it step by step. I can even tell it use Good Mama detergent or use I'm giving it step by step because that's what we call declarative. I'm declaring it step by step on what the computer will do. When it comes to imperative, I don't need to declare everything. All I need to do is just to tell the computer wash my clothes. So I don't even want to care whether it uses washing machine or uses his hand to wash it or he uses Good Mama or whatsoever soap he used to wash it, as long as at the end of the day my clothes shall comes in clean. That's imperative programming. But declarative, I have to define and tell it what it exactly needs to do. You understand? So let's say, for example, now I'm not explaining all the story I'm saying so far. Is just to explain what programming really means. Because to me, the way I learned programming was I had the mindset of it. It's not just about like the way it is now that is so very popular now. People are also into tech. There's some people that don't even really know what they are doing, but they say they are a tech person, they are a programmer, or they don't really even know what happened behind the scene when the computer does some certain things. So there was a guy I read his book. The guy said if you can't write assembly is actually a programming. If you can't write assembly, then you don't even know what the computer does behind the scene. I can't write assembly, so that means me I don't even know what the computer really does behind the scene. But that is a story for another day. So programming in simple terms is just you writing series of instructions for the computer to understand. Writing series of instructions for the computer to understand, as simple as it is. So now What now goes further is now programming language then now gives you the ability to communicate with the computer. So the computer itself only understand one simple language, call it machine code. We only understand this. So this is where we have your binary, we have binary, I'm sure we've heard this thing before. The computer only understands zero and ones and all these things. This is all the computer understand. So before now, people actually program in binary. Those guys that started programming, they actually started this way. But then they now saw that, oh, this thing is actually, if you want to compute something like doing addition of 2 plus 2, this thing can take them a lot of time to actually compute this thing. But now we have on your browser, on your calculator, on your phone, you can just type 2 plus 2 and you get your answer instantly. But the computer only understand what we call machine code. So what these programming languages does is that behind the scene, your computer itself do not even understand all these jargons. They don't understand Python, they don't understand JavaScript, they don't understand C, C sharp, C++, TypeScript, whatsoever program, Go, Rust, they don't understand it. These programming languages are for you. All right, these programming languages are for you. So the programming language gives you the ability to communicate with your computer. So pardon me, but I'm not sorry. The reason why I needed to say all this thing is so very important. I don't just want to go straight and teach you guys and just let's write code, let's write code. I want us to first have a mindset about it before we jump in. But when you have a mindset and you start writing, it becomes so clear. There's some things that you begin to now see that becomes clearer for you because you already have a foundational knowledge of what these things are about. Do you understand? So your computer, so probably later when you're outside and you are talking, when somebody really asks you, okay, what's happening behind the scene, for you to know, people that actually know these things are actually those people that they call themselves software engineers. Now there is a debate that's going on that can AI overcome developers, or is it no? The honest truth is that probably to a level, AI now they are doing some nice things. I won't lie, but deeply behind the scene, and AI, I'm not sure there's any AI now that can even write code for an operating system or can even do things like the algorithm and all those things. But that is behind another discussion. But what I want to pass across is that your computer only understands machine code. So programming language is for you. All right. It's just like let's say I want to talk to David now. But David don't understand my language. David understands Yoruba. And me, I only understand my Edo language. So if I'm speaking Edo to David, but David don't really even understand Bini. Do you understand? But what now comes and help me to successfully communicate with David are two things. The first thing is what we call a compiler, and the next thing is what we call an interpreter. All right. A compiler compiles the whole language and now narrates it to David. So now, if I want to speak to David now in Bini, I'll write everything I want to write in Bini. Then the compiler will come, take all those things that I've written in Bini language, compile it and translate it to Yoruba that David understand. You understand? But interpreter now is, as I'm saying it, is telling David instantly. That's what an interpret, just like how we do it in church, that there's a pastor speaking English, then they have an interpreter saying it in Yoruba to the congregation. The pastor is saying it, the person interpreting it in Yoruba is saying, if the pastor saying one line that opens to the book of John, that one to interpret, in Yoruba. But for compiler, the guy will have to wait for the pastor to say everything that I want to say, all the sermon you want to say, all the 2-hour sermon the pastor wants to preach. Then we'll now come and take everything and now start translating it for the congregation. Those are the two things. So initially, all these languages that we have here, that are over hundreds of programming languages, are for us. They are not really even for the computer. Most of them are categorized into low-level programming language and high-level programming language. So let me write these things down. Low level we have low level, and we have high level. So when we have low level programming language are languages that are way more closer to machine code. They are way more closer to how to explain it. They are still not as easy to understand in English. High level language are languages that are very, very, really close to English language. If you see some programming languages, they're actually very easy for you to read. If you see function, blah 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 blah, and you see all those things, they are like you are writing English, but in kind of like in a mathematical term. But low level languages are language you don't be seeing jargons, you be seeing some extra things that you don't even want to see and stuff like that. Okay, you know what? Let me show you how a machine code actually looks like. Let me open to one of my projects that I've done. Where are all these projects? Let me show you what machine code looks like. Which one should I use now? Mm, Okay, let me use this one. I think I should have a compiled. Oh, this guy is empty. I think I should have a compiled um project here that you can see. Where are all these projects? Let me use this one. Let me see if there's anything inside. Okay. So we have. So let me show you how the code a machine code looks like. Okay, I think I've seen it. Let me open the DLL file. So let me show you how it looks like. It's jargons. So that is those are the things that your computer understand. All those jargons. But now the computer does not really even care about what Python is, JavaScript is, C, TypeScript, or whatever. The only thing all these programming languages are even used for is that they have their own particular importance. Like Python is like the scientific language, Java, some stuff like that. Let me see. This is not even what I want to show you. This guy is not giving me what I want. Where is this thing now? Let me look for it. I don't have all these ones are not compiled. Am I supposed to even check? Let me look for it. Let me check OBJ if I would see. This is what I'm looking for. This is what I'm looking for. I don't have anyone here. If not, I will show you how this guy actually looks like. It's very rubbish, very jargons. You can't even if I should tell you now that you should write a code that will do all these things, I'm not sure you can even look at it and write it. Because it's very, very rubbish. It's very nonsense. I don't have them here. They're not here. Okay, I think they're here now. Well, let's just continue, Sha. Probably another time I'll show you how it looks like. But what I'm trying to explain now is that low level are the ones that are far away from looking like English. High level are the ones that are closest to us. For example, now Python is an high level language, JavaScript is an high level language. C, for this guy, I feel like C is in between. I feel like C is in between low level. I don't even know. Some programmers hate writing. People that write C are people of programmers of the ages, those ones that started with it. But now it's rare for you to even see a programmer and say, okay, let me learn C. But though at that time then, but all these programming language you are seeing here were all originated from the C programming language, like Python, JavaScript, Java, C Sharp, C++, and all those guys. All those guys they originated. They are just extension of the C programming language. So now for TypeScript is an high level programming language. Java and C Sharp are high level, C++ are high level. Some low level programming language we can have is Fortran. I'm sure we've heard of programming language called Fortran. I'm sure we've heard of COBOL. I'm sure we've heard of Ada, all these crazy, stupid programming languages. So these ones are actually very, very low level. They are still far away from looking like English. They're still far away looking like natural language. But high level language are like these guys. So now, although the story I'm telling you guys is so very important, and please, I know it might look boring, but I want us to understand so that we're not just learning how to write code, we're learning every single thing relating to programming or in computer science, So when you're going out or when you're working, you're not working with just coding. No, the difference between coding and programming. Coding is, you're just doing that, you're doing it for fun. But programming is you going inside, understanding hardwares, how things happen behind the scene, what happens when you turn on your computer, what happens when you search for a web page, what happens when you go to your Google browser and you input something and you see all those links, you click and you go to a web page to all those things are actually very, very important for you to know as a programmer. All right. So we have machine code that, or if we don't call it machine code, we can call it object code. Right. Another name we can call it is object code. So now the second guy we need to know is what we call a source code. Right. A source code is the code that you will write depending on whatsoever programming language you are using. It's called a source code. So now either the compiler or interpreter takes the source code and translates it into a machine code that your computer understands. So like I said, the two different examples here is that a compiler will wait for the pastor to preach his 2-hour sermon finish before he now translates it to the congregation. So if I write, for example, now if I write a code now and I write 1 million lines of code, if I want to do this guy, what will happen? If I want to run that code, the compiler will take the entire code that I've written, compile everything all together as one, to compile it once and for all. But interpreter, in this sense, doesn't compile everything once. Interpreter reads it line by line. So if we have 1 million lines of code, interpreter will read line 1 and execute, come to line 2 and execute, line 3 and execute. That's it. It's just like a pastor is preaching and say, Jesus Christ did it. The interpreter too have to immediately then interpret it in Yoruba. He's not waiting for the pastor to say everything finished before he interprets. So that's the difference. So for example, now, example of a compiler is like C# now. I don't know. I think C# is hybrid. I don't know. I can't remember. But Java is a compiler. C is a compiler. C++ compiler. But interpreter is like Python, JavaScript, TypeScript. All those guys are interpreter. So now what brought me here was explaining what programming really is. So programming is the act or is the process of writing series of instructions. Writing series of instructions for the computer to understand, or writing series of instructions to tell the computer to do tasks for you, to do tasks, telling the computer to do some things for you. Because behind this, the human brain can calculate 2 plus 2. All right, 2 plus 2 is 4. But me, I can't calculate 2 raised to power 1,000. Something like that. I can't. My mind, but I can calculate it, but it can take me a lot of time, to do it. But the computer can do that within milliseconds. That's what the computer is used for, to make sure that we do things very snappy and all of that. So we have the machine. So I will just give a brief. You have the low-level programming language, high-level programming language. All these guys are like example of a programming language. We have the machine code that the computer understand, or we can also call it object code, right? Then we also have the source code. That is the code that you will write, either using any of these programming language. Then we have a compiler that I've forgotten all at once. All at once. So this guy compiles, interpret everything all at once. The interpreter does it just in time, right? Just in time. So if you have 1 million line of code, the interpreter will be interpreting line 1, then execute it, line 2, execute. But compiler will compile every single thing as one, then execute it. That is how it's done. So now, what came to it now that this text editor, which is Visual Studio Code, right, is now is the medium where we now write programming language. Is with the medium that allows us to write programming language that will allow us to write instructions for the computer to understand. So for example, if I want to write a letter to Gideon, do you understand? But Gideon only understands Latin, or Gideon only understands his tribe language or whatsoever. So me, I only understand Beni, but Gideon understands Latin. and I want to write a letter to Gideon, or I want to write a letter that will allow him do something for me. Do you understand? So what I need to do now is I pick my book and I pick my pen. In this scenario now, my book now stands to be my Visual Studio Code. I pick my book, I take my pen, then I write that letter to Gideon. I say, oh, please, when you get home, let me go to Mama Nkechi's shop and buy something for me. Then I write the letter, I put the letter into an envelope, and I give it to the post office. Then the post office now, carries it to Gideon's house. But Gideon doesn't understand the Benin that I wrote inside. Gideon understands Latin. So depending on the language, Gideon can now employ a compiler or an interpreter that will translate that letter for him. So if it's a compiler now, a compiler will read all the single thing in the letter, then now narrate it to Gideon. But if the person Gideon is paying as an interpreter, as the person reads the first line or the first sentence of the letter, he now tells you that, oh, Samuel said that you should do this. Then line 2, Samuel said you should do this. But if it was to be a compiler will read all the letter, all the contents in the letter, they now translate it to Gideon once. But interpreter who is interpreting or translating one line at a time, just in time, interpreting it just in time, just in time. Do you understand? So now, in that sense, now I'm not going to bring it now to the programming term. Visual Studio Code is now the text editor where we can write programming languages to tell the computer what to do, as simple as it is. So the general name we call it is a text editor, right? Example of a text editor can be your Microsoft PowerPoint. Even this notepad I have open that I'm using to jot is also considered to be a text editor. So there are also so many different other examples of a text editor. Apart from Visual Studio, the only one I can say is even still good, what we call Sublime Text. Sublime Text. You don't need to know this thing, but I'm just mentioning, just so in case outside somebody is saying I'm using Sublime Text, so you not say, Samuel did not tell me that one. But Sublime Text is an example of a text editor. People also use just like a tool, and we also have Atom. There are different type of text editor. There is PyCharm for writing Python codes. There's some text editor that are specifically made for a particular programming language. For example, now PyCharm now, as the name implies, PyCharm, we use it to write Python. There's some programming language like Intelligent, I've forgotten the full name. That one is used to write Java. Some text editor are specifically used for one particular language. But glory to God for Microsoft creating Visual Studio Code. Visual Studio Code is not created for one particular language. You can write Python, JavaScript, C Sharp, whatever programming language using Visual Studio Code. So Visual Studio Code is always the go-to text editor for any programmer to use. All right. So Visual Studio Code, you can, it has all these tools that can help you write code faster. It brings out suggestion. You have all those shortcuts, keyboard shortcuts you can use. Very easy. Instead of you thinking on how you can copy and paste or how you can move some things, Visual Studio Code gives you those tools to write code effectively. And as well, in Visual Studio Code, we also have what we call an extension. So extensions are just extra tools that can help you to do something. So let's say I'm writing my code and the code is messy, there's no proper indentation. I can use an extension to help me, arrange my codes, make it just like if I'm writing a letter and I see my handwriting are not really aligned properly. And I know that it will be hard for Gideon to read the letter. So I can have an extension that will help me arrange my letter properly, check for the places that need full stop and make it look neat so that Gideon can successfully read it. I will call them an extension. So now the next tool that we're going to use is what we call Git bash, right? Is a CLI, right? So and CLI stands for a command line interface, right? CLI stands for a command line interface. So now let me now come back to another important story. For example, now CLI, like I said, CLI stands for a command line interface, right? CLI stands for a command line interface. So there are two major interfaces you have in your computer, right? The first interface is what we call the graphical design. Okay, I explained these things during the last class. That means I'm just going to do a brief explanation. We have the GUI, graphical user interface. We also have the CLI, which stands for command line interface, right? So basically, the GUI have graphical representation of what your computer have. Like you can see all these folders that are here. They are graphical representation of my computer. Why CLI does not necessarily, I don't have any relationship to do with all the jargons. This is how a CLI looks like. A terminal. I'm sure most of us we know we've heard of command prompts. So for example, now this is what a CLI looks like. There is no extra button that I can click to do anything for me. All I do, everything I can do here is by typing. All right. Actions I perform are by typing. So we call them text-based commands. That is what we call them. We call them text-based commands. So now I'm sure I explained all these commands during the last class. PWD, print working directory, make directory, ls, cd, touch, remove, and all these things like that. So even though we didn't fully get it during the last class, I'm going to I'm going to start over again, which is something that I don't really do, but I'm going to do it. So let's say now we want to work in a particular project. Let's work on our first project. Let's build our first project. Let's work with HTML for today. All right. I'm not sure if you can even go deeper into it, but let me just, let's touch it. So now, if I want to start a new project, so the first thing you need to know is that where would that project be saved? Where should I save that particular project? Remember, I gave a story before during the last class that your computer consists of directories and files. I mentioned that your computer consists of directories and files. So directory in the sense that I mentioned that a directory is also called a folder. In a layman term, a directory is called a folder. All right. So all these things you are seeing here are all folders. That is what my computer consists of: a folder and a file. I also give you the differences between how you can differentiate between a folder and a file. I mentioned that a file must have an extension. All right, a file must have an extension. I gave an example that when an extension is the dot whatever that is in a file name, that's an extension. For example, this file now have an extension of .html, .css. I'm sure we can see if it's a Python file to be main.py, right? Main.py, that's the extension. If it's okay, let me do it this way. If it's a Python file, we have main.py. If it's a JavaScript file, we have scripts.js. If it's a C file, I don't even know what C is, honestly. So if it's a TypeScript file, we can have type.ts, right? TypeScript. If it's a Java file, we have main.java, right? If it's a C# file, we can have main.cs, that's C#. If it's a C++ file, we have main.cpp. All right, so all these things here are extensions. Extensions are important to indicate what content that file can hold. All right, so it means that if I'm creating a file that has an extension of .py, I can't come and write JavaScript syntax inside. If I'm creating a file that have .js, I cannot come and write, Java codes inside JavaScript file. Java and JavaScript are two different programming languages. They are never the same. They don't even look the same at all. They are two entirely different something. The only programming language I can say that they are the same is TypeScript and JavaScript. All right. I can as well write some JavaScript code inside TypeScript, but that is a discussion for another time. But this is what we call an extension. So if you want to create your project, you need to make sure that a project, must have its own directory. That means a project must have its own folder. Right, a project must have its own folder. I mean, if you could see all these things I have here, so all these projects I have here, I created them in their own particular folder. I think I have a folder called 2023. Okay, I have a folder called. So inside this folder now are the codes that I've written 2023. That is like 2 years from now. Most of the ones I have here are the ones I worked on 2024, but I've not just arranged it that way. So some of them are the ones that I've worked on this year. And you can see the way I separated everything for easy access. So later in the future, if I'm looking for a particular project that I've done in the past, I don't need to start going inside my system and start looking for it. I know straight down that, okay, I'm looking for the Mimvex project. All I need to do, is just to open this directory, and I have all the projects that is relating to this Mimvex. I have the backend, the front end, the blog, or what. You can see the way I separated everything. So this backend directory now is talking about all my backend codes. I wrote this, I built this project using Node.js, that is JavaScript. The front end using React. I could see the way I separated everything, looking clean. Even if I open this backend directory, I still have more directories inside there. I still have more files. You could see how this particular file has an extension of the JSON. This one has an extension of the JS. I mentioned before that the extension can start at the end or can be at the beginning. Sometimes, in fact, the extension is the file name. For example, if you can see .gitignore, .gitignore is actually the extension of the file. .env is the extension of the particular file. You can see the way everything is being arranged in my project. So we're not only just going to learn how to write code, we're going to learn how to write code the right way, the proper way, the industry ways, because I've been fortunate to work with some people, some startups and some software companies, and there are some ways you do things. If I'm working for myself, I know I don't need to do this thing. It's not my concern. I don't even need to save it. I don't even need to save this project particular way that I did. I can just put all these things anywhere I want to put it. But it's not proper. The reason is because when I want to now work for people, or when I want to now build a standard life project, it's going to affect me. It's going to affect my work ethics. Let me give another example. I think I have a directory called projects. Where's project. Okay, this project here. So if I open project, you could see now I have all these guys arranged. This is a project relating to one particular company. You can see I have everything here. Fitflex API, Fitflex API service, Fitflex app, Fitflex blog, Fitflex FMS, Fitflex websites, the mobile front end, Smile ID. You can see where I arrange everything into a separate. So I know it's very easy for me to now access this thing. But let's say this particular directory now is saved inside one place in my laptop. I'll now start going up and down to look for that project, which I don't want to do. As a programmer, you should not even let this kind of thing stress you. The only thing that can stress you as a programmer, let it only be to write the code. But things like creating your project, installing some things, and all those things are something that you don't want to let it stress you. The only thing you should stress yourself about as a programmer, that is to fix bugs. Programming, let me just tell you the honest truth, programming is just 80% fixing errors and 20% actually writing the one that works. That's the truth. Let me just tell you now so that you will know. It's 80% fixing errors, or we don't even call it errors, we call it bugs. We call it bugs. Bugs in the sense you have like mosquito bugs and everything. So that we have bugs in your code. And 20% actually writing codes that work. Right? Actually writing codes that work. That is 20%. So we spend 80% of the time fixing errors from the code we write first. Then we now spend the remaining 20% is now we writing codes that actually work. So let me just actually even tell you all the the things you need to get ready for in learning this thing. And it's up to you if you want to drop or you want to continue. All right. So that then later in the future, you don't say, oh more this thing want to break my head, or oh more this thing is hard, blah 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 blah, and all those things, you don't have to cry about it. So like I said, it's 80% fixing errors. We call it bugs, and 20% actually writing codes that work. You understand? So let's say I want to write a code to do something, then I write the code. But to my own knowledge, I've written the code the way I feel like it will work. Do you understand? Okay, let's say I want to write a code that we add two numbers together. I say 2 plus 2. Right. Me, myself, I know this guy's supposed to equate to 4. But after writing the code that will calculate that number together, at the end of the day, my computer is giving me 10. I mean, my code doesn't work. I have a bug in my code, But to my own knowledge, I feel like I've properly written that code that will work. But the honest truth here is that that code didn't actually work. So now that's what I'm trying to explain to you. So I have to now spend time to go back to the code that I wrote that I thought was correct, to now fix the code to now make it work. So now what I said is now that writing code is 80% fixing errors, whereas 20% actually writing codes that work. So it's a miracle if you write a code for the first time and that could actually work. I'm like, hey, You understand? Something that, and another rule I will tell you is that if it works, do not touch it. Right? If it works, do not touch it. If your code is working today, that code is expected to work even 1 million years to come. All right. So, but once the code is working today and tomorrow the code doesn't work again, the reason is because you've not written that code to work for all test cases. Right? I call it test cases. Right, that's what I call it. So, okay, let me give an example. I'll give you that 2 plus 2. So, I want to write a code to add two numbers together, 2 plus 2, which is equal to 4. So, to me, I feel like, okay, if I write the code, if the user passing 2 and passing 2, I'm sure the answer should give me 4. What if the user now go and pass 2 plus b? This guy will actually throw an error. But at the time where I wrote the code, when the user entered 2 plus 2, it was working fine. So me, I felt like, oh, that means this code, 100% is working fine. There's no error. But the next day, instead of the user to enter 2, the user mistakenly enter B. By that time, this code should return an error. So now in this case now, this code is not pure. It's not even correct. It's not working. It's not working the way you're expecting it to work. So now these are like the truth I need to tell you, because when you go further, you start seeing something that we want to bust your head. Writing code is 80% fixing errors, then 20% actually writing code down. If it's not possible, I can even see increase this gas like 90. But not to scare you guys, it's just the actual. That's why I said the programming is just the mindset. When I give you a problem to solve, if I say, okay, write a code that will do this, what you need to first do, first of all, is to think on how you can solve that problem. Then the programming language is now you first have to solve it in your head first. Solve it your own. Solve it on your own. Then the computer is now meant to help you make sure it can solve that problem for you faster and way better than the way you've thought about it. That's the honest truth. So the programming language programming language itself is not even the coding part. You thinking and constructing the language, constructing the syntax is now what we actually call programming. So the language is just giving you the aid to communicate with the computer. So that is one of the biggest stereotypes that I want to debunk, that coding is I know how to write 20 language. I can be able to only write Python, and the things I can do with that Python can surpass all the languages that you know. So it's not only about the language, it's about your approach to solving the problem. But there are some problems that Python can solve faster and easily than JavaScript can solve, or even other programming language can solve. But that's not the case. What I'm just trying to explain now is that if I give you a problem to fix, if I tell you now that, okay, take my name now as Samuel. What I want you to do now is that I want you to divide this word into 2 syllables. That's a very crazy project that I've been given before. So you knew now that Samuel has 2 syllables. That is Samuel. That means you have to put a space in between here. So now I'm telling you now to write the code that will take any word and divide that word by the number of syllables it has. Like umbrella now. Umbrella. How do you spell umbrella again? Umbrella. Am I correct? Hey, it's my life. Umbrella. All right. So now umbrella has umbrella. Umbrella is 3 syllables. Umbrella. So your solution is supposed to take umbrella as a word and divide it into 3 based on the number of syllables. That's a very crazy project. So if I give you now, how will you solve that thing? I'm sure you do. So your programming language will never help you at all. The programming language will not tell you that, oh, this is how you're supposed to do it. Though. You first have to think like somebody wants to run mad. But now you can solve that problem. Then you can now say, okay, let me now use the programming language to tell the computer to help me do it faster and way better. All right. Programming language will help you do it faster and way better. Another problem can be, okay, take this word A, B, B, C, D, and return it in this way. That will be A. How many A are there? 1, 2, 3, 4, 5. That will be A5, B2, C5, D7. These are actually what we call lead code problems. These are problems that all those big companies give programmers to know that you don't just know how to write programming language, you know how to strategically think and fix these problems. All right, so that's what I just want to explain. So this is what I just want to, let us understand that it's not just. I'm sure there are some days that you feel like, come on, this I need to do again. Or some days that you feel like me, I've given up so many times, but I still come back. So there are some days that I say, more this thing is for now. Sabi they do. I'm dropping it. But the good thing here is that when you keep on learning, you keep on going on and on and on. Everything just keeps on getting better. So that is what I want to train. What I want to train is your ability to think and know how to solve the problem. So, but mind you, that all those problems that I've given you, I can solve it using any programming language of my church. I can solve it using Python, Java. So in that case, is the programming language now the act of programming? No, that's the programming is you writing the series of instructions to now tell the computer that, oh, computer, oh, I want you to do this thing. Oh yeah, when you see something like this, do this, do this, do this, break it down, separate it, do it this way, take this one and move it to the back, take this one, as simple as it is. So the programming language is just what gives you the access, the connection between you and the computer itself. So now going further now, I want to explain how you can successfully start a project. All right. So make sure that your projects are very, very organized. Considering my own is I organize everything in a very, very good way. So the first thing you need to do now is to open your Git bash, right? Open your Git bash. So you need to open your Git bash in your home directory. So I call the home directory your desktop. So your desktop is very easy and it's easy for you to access your things. So anytime you switch off your computer and you bring it up back, the default place your computer goes through straight is your desktop, right? So make sure your desktop is your home directory. So in that sense, it means that if you want to create any projects, I prefer and I advise you to create it on your desktop. The reason is because you can access them faster. If I want to open up the project that I've done 2023, all I need to do is just open 2023 directory and voila, I have all the projects that I worked on, in 2023. If I want to, so that is how you are going to make sure that you arrange your thing. So I want to create a project and call it what should we do? Let me just call it about myself, right? Let me just call it about myself. So the first thing you need to do is to open your Git bash in your home directory. And to open your Git bash in your home directory, what you need to do now is to right click on an empty space, right? Make sure you right click on an empty space. So if you don't see the option to open Git bash first showing here, what you need to do is to click on show more options. So when you click on show more options, then you see, open Git bash here. So when you click on open Git bash here, then voila, my Git bash opens by itself, but my Git bash is going to open on my desktop, which is my home directory. So you can see desktop printing here at the end, which is my working directory. I explain what working directory means. The working directory means what folder is my Git bash currently on. What folder is my Git bash currently opened, which is my desktop. So to confirm that, I can use the pwd command. So pwd stands for print working directory. It's going to print out what directory or folder did my Git bash open, or what folder am I on now. Remember, the rule here is that whatsoever you do in your Git bash will always affect your working directory. So whatever command I do here, whatever thing I do here, will always affect my desktop. All right. My desktop is my working directory. I gave this example. So take your working directory as your room. So you are in your room right now. So that your room now makes it your working directory. So me, for example, now I'm in my room. My room now makes it my working directory. But all this, what is now these jargons that are showing here? This jargon showing here is what we call a path. P-A-T-H. We call it a path. So it's just series of places or directories that your Git bash needed to pass through before it gets to your working directory. Meaning that I'm in my room now. Before I can get to my room, I needed to pass some places. For example, I needed to pass through my house gate, then I passed through the building door, then I passed through the sitting room. From the sitting room, I passed through the staircase. From the staircase, and I get to my room. That is what this guy is actually saying. So this guy is saying you need to pass through this place, then pass through this place, then pass through here before you can now get to desktop that is printing at the end. So that's what PWD. So remember the rule here is that whatsoever I do here will always affect my working directory, which is my desktop. So, but what I want to do now is that I want to create my project. I want to work on a project about myself using HTML. Let us start with that first. So now what I need to do is to use the mkdir command, which stands for make directory. All right, make directory stands for mkdir. So it's used to create your project directory. So now your project directory needs to be very descriptive of what the project is about. So I'm creating a project about myself. So what I need to do now is to name the project about myself. So I mentioned before that when you're creating a directory, you don't use space. In fact, naming anything in any programming language, I don't care what programming language you're writing, don't use space to separate it. If you know you want to create a folder that has 2 words, for example, my folder, my about myself now, 2 words, about them myself. But I want to make it, well, in my own case, I want to make them one. I want it to be the folder, the name of one particular folder. So what I need to do is that I don't use space, I use hyphen, right, to make sure that both of them are together. Then to execute it, I hit enter on my keyboard. Right. So to confirm if this directory has actually been created, I'm going to use the command called ls. Ls, this is it here. Ls, which stands for list. Right? Ls stands for list. So what I need to do now is just to say ls. Then it's going to list out all the contents that are inside my desktop directory. So at the moment you have 2023. Remember, there was one 2023 directory that was on my desktop. Where's 2023? This 2023. So you can see now that my guild badge is actually listing everything that is here. So you can see the difference between the two interfaces. My graphical user interface is listing it out for me in this way, which gives it a very nice design. I can see all these brown folder design. I can highlight, I can drag these things to anywhere I want to drag it to and do all those things. You can see the about myself directory I created here. You can see it at the extreme top. So that's what the graphical user interface does. It gives you this fine looking content in your laptop. But the GUI does not really even care about all those crap. The GUI, the CLI rather, it's telling you more, this is the highest I can do for you. If you don't understand all these things that are here, then sorry. Do you understand? But you can see now that the ones that have forward slash at the beginning of it are directories. All right. The ones that have forward slash at the beginning of it are directories. But the ones that don't have forward slash at the beginning of it are files. All right. The ones that don't have forward slash at the beginning of it are files. So for example, now, let me show. Okay, this guy now is a file. This guy now is also a file, right? So that is the way Git Bash is differentiating. That is how Git Bash is differentiating these things. So now going further, so you can see now to confirm, you have I'm about myself. That is to confirm now that that directory I created is actually here. About myself is here. So now the next thing I need to do now is to open that project directory. I want to open that project directory and start creating the files and the things that I need to start programming. So for me to do that, I need to go into that directory. At the moment, my desktop is my working directory. Remember, I mentioned that whatever thing you do here will affect your working directory. So what I need to do now, and I want to create my project files inside my about myself directory. So the case now is that I need to make about myself my current working directory, because desktop now is my working directory. What I need to do next now is to make about myself my working directory. So to do that, I use the cd, then I say about myself. Now for this to work, two things needs to be possible. The first thing needs to be that about myself directory should already exist. About myself directory should already exist. And thank God now, about myself is listing out here. That means it already exists. The next thing now is that about myself needs to be currently located in my desktop. So now about myself is listing here. That means about myself is currently under what? my desktop. So now that two rule will make sure that this command runs successfully. So if I hit enter now, you can see now that about myself now is my current working directory. That means I've changed my working directory to desktop to about myself. I mentioned that whatsoever command you do will always affect your working directory. So the reason why I needed to change my working directory to about myself is because of I want to create my files here. So if I don't do this, if I create any file, that means I'm creating that particular file under desktop and not about myself. But that's not what I want to do. What I want to do is to create that file under about myself. That is the reason why I needed to change my current directory to about myself. So I also mentioned that this command can only be possible if about myself already exists. And to do that, you have to create it. So that is what we did here. We created it using this command here. So the next command, the next criteria is that about myself should exist in desktop, should be inside desktop. It not only should even exist, it should exist inside desktop. Just like, let's say in my room now, I have a toilet in my room. So for me to actually go inside that toilet needs to, number one, the toilet needs to exist. That means the toilet needs to be real. Then the next step is that that toilet needs to exist inside my room. I cannot go inside the toilet if the toilet is in my mom's room. That means before I can go to the toilet, I need to come outside from my room and go to my mom's room. But I can only go to the toilet from my room if the toilet exists and also exists in my room. It's also inside my room. So those are the two criteria that you need to look out for. So the next command now is, okay, I've gone inside this my about myself directory. The next thing I want to do now is to create a file that will start working with. So the command to do that is what we call touch. Right? I say touch, then the next thing that comes in will be the name of that file. So the name of the file is going to be index.html. So remember, I explained about files. The file extension indicates that what content the file can hold. So I'm using .html content extension, which means that I can write HTML codes inside this particular file I'm creating. Please and please always remember that when you are creating a file, always put the file extension at the end. If you know you want to write CSS codes, you name the file touch whatever.css. If you want to create a Python file, you are creating touch whatever.py. Do you understand? But now I want to create an HTML file, I need to know index.html, right? So I execute this command. So after executing it, it doesn't give me anything in return. But how do I know if this file has already been created? What I need to do is to say ls. Right, I use the ls command again to list. So when I use the ls command, it's no longer showing all these jargons because all these jargons exist under desktop. But now I'm no longer under desktop. I'm under what's about myself. So the only content that will be listed out here are contents that are on the inside word about myself directly. So at the moment, we only have one file called index.html. So after creating the file, the next thing I need to do now is that the reason why we're creating a file is that the file is where we're now going to write our programming codes, right? Using a programming language. So take this file as the leaves in my book. Remember when I give a scenario when I want to write a letter to Gideon. Take this particular file we just created now as one particular leaf. So that leaf, that page rather, needs to exist so I can start. I'll carry my biro and start writing the letter. So that is the reason why I needed to create the file. So this guy now is my page where I can now start writing code. So if I can start writing code inside this particular page or file, what I need to do now is to make sure that my book is open. I need to open my book. So now what I want to do now, the next command is how can I open this particular directory? Take about myself now as the entire book. Take the about myself as the entire book. Take index.html as one page in the book, which also indicates now that I can have multiple files. That means I can have multiple pages in a particular book. So I can say touch. Let me create another one. Let's say about.html. Once I use enter to run it and I use the ls command now, I have two files, about and it. So this is like page 1. Let me say this guy is also page 2. So about myself now is the book itself. So all these guys you are seeing here are just pages in the book. So now for me to now open this book so I can now start writing my letter, I need to open this book in my Visual Studio Code. That is my text editor. And the command to do that is code, right? I need to write code space, then I press dot. Code space dot. Right. Code, when I run this code space dot command, this code space dot now will open this particular book called About Myself in my Visual Studio Code. So you could see now something does pop up by the side. If I come to it now, you can see the two pages I created, about.html and also index.html. So I just explain the process on how you can start creating. This is the step you'll be following. As a programmer, this is the step you follow. That is the reason why I needed to tell you all this story, all this jargon story. That's why I needed to explain low level, high level, programming, CLI, all the jargons you are seeing here and all this rubbish are just so to explain how you can start a project. So the first thing you need to do is to open your Git bash on your desktop screen. And I explained to do that, all you need to do is just to right click on an empty space, put your cursor on an empty space, right click on the empty space, right? Then go to show more options. From show more options, you now click on Git bash here. So when you click on Git bash here, it automatically open, your Git bash from your desktop. So if you can see, I just open a new one. Let the guy loads. Once it loads, you see now that it's opening to open that. Can you see desktop is putting at there, meaning it has opened its Git bash from my desktop. The next thing you need to do now is to create the directory of the project, your project directory. You can call it whatever you want to call it, but make sure that the project directory is descriptive of what the project is about. If I tell you to build a project for a car dealership website, you have to call that project car dealership. Don't call it your name. Reason is because if you've done something mad in that project, and later in the future, you now start another project again that has that same feature. Me as a programmer, I'm not mad that I'll now start going through the process of doing it all over again. What I need to do is just to go to the former project that I've done it before, copy it, go and paste. I'm not a righteous programmer. I'll copy it and paste it as long as you're doing like it the first time. Do you understand? So that what we call, you are making your code work for you. So as a programmer, let me tell you how programmers make money. So if I create an e-commerce website now, right? E-commerce website follow some particular features, like for example, authentication feature. But that means a user can log in, sign up, forget password, and all those nonsense. The next feature can be adding a product to cart. The next feature can be payment. Next feature can be searching for products. All those things are one of the default features that go on and on in different e-commerce websites. So maybe the first time I'm building an e-commerce website, I'll do all the work. I'll create the authentication feature, create the cards, create sign up, login, password, forget password, email, all those nonsense. I'll do everything. Then another time, if another clients now come and meet me that, oh, Sam, I want to do e-commerce website too. Are you now telling me now that both of us are in this corner? Are you telling me now that I will now go and start building everything again from scratch? I'm not mad. I've done e-commerce website before. All I need to do is just to pick those core feature backend codes that I've done. The only thing that I will change is only the UI, the design of it. But behind the hood, all e-commerce websites follow the same logic, meaning you shall log in, you shall sign up, you shall click the product, you can view more details of the product, add the product to cart, go to your cart, select the quantity you want to buy, put in your address for delivery. After you do, you proceed to payments, put your card details, proceed to payments, payment is successful, money deducts from your account. You still follow that same process. The only difference will just be the design, the UI design. So that is what you say, make your code work for you. Your code now becomes your asset. Your code now make money for you. So in that case now, if a new person comes to meet you now that wants to build an e-commerce website, at that point the person is coming to meet you, you've done 50% of the work already. The only thing left is just the design, because you know what to still give the person the same design. So you should know your two clients will not be having the same design. No, they'll come and arrest you. But the thing here is that you do the same, but behind the hood, Gigi, Jumia, all of them are still the same. It's still the same, backend logic like that. Maybe some things are just different, but behind the hood, 80% of everything is the same. Still the same process it follows, So That's what we call. But the first time you are building an e-commerce site, that's when you do all the work. So that is why, as a programmer, you need to do things in the correct way. That means if you are building an e-commerce site for the first time, if you are doing the authentication feature, write the code in a way that you can still reuse that code in another project. Don't make that authentication feature dependent on that project. Meaning, if I take out that code and put it on that project, that code will not work because it's depending on something that is already in my e-commerce project. Almost all projects have authentication feature. Facebook, to access these things, you must log in with email and password, forget password, OTP, get your OTP, all those things. All applications follow that same feature. So when you create something like that the first time I created an authentication feature, I flopped. I made a mistake. I made it so dependent on only that project. So if I now want to do another project again, I'm just repeating myself. I'm not typing the same code that I've typed before all over again from the beginning, which is not meant to be. As a programmer, don't repeat yourself. It's a rule. It's a rule we call in programming. So when you see it, DRY, right? It stands for don't repeat yourself. So as much as possible, when you are doing anything, don't repeat yourself. I'm saying this thing. If I give any project and I see that you are writing code in a way that I know that you are not supposed to write it, or more, I can score you 0. Do not repeat yourself. Make sure as much as possible you don't spend time writing codes that you've written before. I made that mistake before, and it actually cost me a lot. And now I have to build another project again where the authentication feature is not depending on that project, meaning that I can copy the authentication feature and put it on another project and it will still be working fine. Do you understand? So that means once I've done that, the only thing is only maybe some technologies have changed and maybe some things have changed in the industry. I have to go and update it. But as much as possible, that code is already there for life. Meaning that you understand, meaning that any project I want to create later in the future that has anything to do with login, register, sign up, forget password, OTP, and all those jargons, I already have it down. So that if you're coming to meet me, I already have those codes. All I need to just copy it as I've done it before and put it in a new project, and everything is working very, very fine. So the next feature can be if you've done any feature relating to payments, meaning that somebody can put an amount. After you proceed, you can now put your card details and you can proceed to payment. You've done it in a formal project before. All you need to do is just to copy that and add it. So that's why it's when you write the code once, make sure that code works for life for you. That is the rule. So I'm not going to teach you how to just come and write code and blah blah blah. You go. No, the way I'm going to teach you is how to do it the proper way. All right. So that will be all for today's class. During the next class, we can now start. We're going to start how to write code properly. I'm going to cover how to write these codes. I want to stop the recording. This guy don't want to. Right. So I'm going to cover. So I want to hear from. Okay, wait. Let me stop this recording before. This guy don't want to open. I want to actually stop recording. I want to stop recording this thing. This thing don't want to open. I want to stop recording my Visual Studio don't want to open. I say Visual Studio. See me. The Telegram don't want to open. Have you guys been hearing me since?
Yeah, yeah.
Yeah. Thank God though. I want to pause the recording. You know what? Let me just cut the call. I will put the call again so you can join. Maybe that will stop it.
Okay.